here's the answer key for the analytical apps of the derivative study guide for the BC course. So we look at problem number 1. Let f be a function. We have f prime here. Which of the following intervals is f concave down? All right, so we know that f is concave down when f prime is decreasing. All right, so we're looking to see when is f prime decreasing. So I bring in the calculator. I've thrown in all of the 3 equations on this page onto the equation editor, but I've only activated the first one. The other 2 are not. So we're going to look at the graph of this function. So I'll start with a zoom. I notice that everything here, our decimals are pretty close to 0. So I'm going to do a zoom 4, zoom decimal, and then here comes our graph eventually. All right, and we can see that it looks like the graph is increasing and then decreasing and then increasing again. And therefore, we're interested in the points where it is decreasing, that interval. So it looks like, well, first of all, there's a couple things you can do here. You can do a max finder. So if you go to second calculate, you can actually find the maximum and minimum and get the exact values. I think we can probably get this squared away with the trace function. So if we trace, because we know what our numbers are that will work here. So let me trace to 0.116. All right, and when I do that, it does seem like that is pretty close to the, if not at the top of the curve there at the relative max. But I do also have a 0.673, so maybe I'll just trace to that. And I can see that that's actually where the function crosses the x-axis. So we do want here, and then again we want let's trace to 2.062 and just make sure that that gets us down to the bottom of the function of the curve there. It's actually off the screen, so I'm gonna have to change my window real quick, drop my y min down a couple more. So let me pull up the graph again. Come on, there we go. All right, and we'll trace to 2.062, and there it is. Okay, so we can see there that the max of the derivative is at 0.116, and the min is at 2.062. So the function is decreasing in between, and when the function is decreasing, this function being the derivative, when the derivative is decreasing, the original function is concave down. So we got C. For number 2, second derivative, how many is given to us? How many inflection points does the graph have on the interval from 0 to 3? Okay, so I'm going to go to my y equals. I'm going to turn off the first y, turn on the second one, and I'm going to go to my window button because I only want the interval from 0 to 3. So I'm going to change 0 and 3, and we're interested in an inflection point. An inflection point occurs when the second derivative changes sign. So I don't really need a huge variation off of the x-axis here. So I'm actually going to make this negative 1.1 and 1.1. So it's going to get me pretty close to the x-axis on the interval that we're looking at from 0 to 3. And let's see if we see how many times. All right, we go. Looks like there's 2 of them there, and then a third one, and a fourth one, and a fifth one. So it looks like the answer is going to be 5, but you know what we're going to do here? Let's just verify this. Let me go to the window again, and let's make this 0.1 and negative 0.1. And now, as we graph this, we can clearly see 1, 2, come on, 3, and 4, and 5. So there are definitely 5 instances where the second derivative changes sign, and therefore we know that f double prime changes sign. That means that f has a point of inflection. All right, and then last but not least, number 3, let f be this function given by f prime. On which of the following values on this interval does f attain a relative max? All right, so f has a relative max. That means that f prime is going to change from increasing. I'm sorry. Well, the function is going to change from increasing to decreasing. So f prime will change from positive to negative. All right. So we're going to go back to the graphing calculator. Y equals. Turn off the second function. turn on the third function, hit the window button. I'm interested in the -4 to 1. All right, doing that, and now that I've got that down, I can get this back to like -6.1 and 6.1. And if we graph it, we are again looking for a change from positive to negative. And it seems like we only have one occurrence of that, and it's happening right there. So it's 1, 2, 3. So it's -3 point something. It looks like we only have one answer. That's -3.623. So let's trace to that. And there it is. All right. So at that point right there, the derivative changes from positive to negative, which means the function changes from increasing to decreasing, and therefore f has a relative max. So our answer is A.